Okay, this is chapter 12. This is section 12-1. This is this is section 12-1, and this is recording number 4. Okay, so you look at this formula here, and here it is written out, and when we actually get to the problem, you'll see exactly how it works. Okay, now here's the formula for the F test in a very concise format, same as what I wrote before. Okay, and then this is always going to be the test. The hypothesis is going to be as follows. The hypotheses will be as follows. The hypotheses will be that all of the mu's, all of the population means, are going to be the same. So the population mu, the mu sub 1, equals mu sub 2 equals mu sub 3 equals mu sub 4, and so forth. So using our example of the cars, we've got population 1 is the small, population 2 is the sedans, population 3 is the luxuries. And what we're saying is that the mean, the population of the smalls, a mu sub 1, that's the mean of the smalls, is equal to the means of the sedans is equal to the means of the luxuries. So mu 1 equals mu 2 equals mu 3. That is our null hypothesis. The alternative hypothesis is at least one of them is different from the others. Okay, so that's what he says right here. Now, what you're always going to see, of course, is the numbers are not going to be exactly the same. One of them is going to be bigger than the other. So if you're a talk show radio host, you jump to the conclusion, oh, okay, look at this. One of them is bigger than the other. That guy must be different from the other two. But that's not scientifically sound. In order for you to decide that there is a statistically significant difference, you have to do the analysis of variance. Okay, so now what I'm going to do, the ebook is correct, but your printed version, at least for the edition number 10, has some typographical errors in it, and I'm sorry about that, but what can I tell you? So let me point out those typographical errors. Okay, so let me point out these errors here. It's very difficult to bounce back and forth. I'm doing the best I can. This page right here, this is the ebook off the internet. This is correct. What's in your textbook, however, is not correct. You see right here, you've got a parentheses and then a quantity is squared. In the textbook, you don't have that squared. I wrote that in, and I wrote typo. Okay, so there's a typo here. There should be a squared in your textbook. And then this right here, that's just my notes to myself telling me where to go to look for that formula where we used this previously. Okay, all right. Oh boy, here we go. Let me fix this. Okay, then you come down here, and ladies and gentlemen, if you're not looking at your book right this second, you're making a big mistake. You should be looking at your book to follow along what I'm doing here. So, and this formula here, you'll notice he has n1 take away 1 plus n2 take away 2 plus ... nk take away 1. Well, that's wrong. That 2 should be a 1. But that's in the book. But in the text, the electronic text, he has it correct. Okay, so what I've been showing you is correct. What's in your book is wrong, unfortunately. Okay, and I think that's the end of the errors in this page. Come on. Okay, so let me close this. Okay. All right, so here's the formula. This is the within group formula, within group variance. What it boils down to is it's the overall variance is a weighted average of the individual variances. The individual variances, he's referring to each of the groups. And the groups being just exactly what we've been saying all along: the small, the sedans, and the luxuries. Okay, so there's the formula for that. Okay, so it's going to be exactly what I told you before. You've got on top the between group, and then the within group, or the pooled data. Okay, now, again, I'm going to show you one more time the way I look at this, what makes sense to me. I have this right next to my right on my desk whenever I'm working these kinds of problems to remind myself of what's going on. On top is how spread out are the means of the group, and on the bottom is how spread out is the data overall. Okay, that's the way I look at it. I hope that helps. Okay, so now the degrees of freedom. What are the degrees of freedom? We have the degrees of freedom for an F test. The degree of freedom, N stands for numerator. The degree of freedom of the numerator is K subtract 1. So K is the number of groups. So for our automobile group, there's three different types of group. There's three groups. There's three different cars, different types of cars. So 3 take away 1, degree of freedom is 2. For the degree of freedom of the numerator is K minus 1. The degree of freedom of the denominator is big N subtract K. N is the sum of the sample sizes. So all of the sample sizes, all of the samples, you have group number 1, N1, plus you have group number 2, you have N2 for that, group number 3, and so forth, okay? So it's N subtract K. The sample sizes need not be equal. The F test is used to compare means is always right tail. So he's just giving you some basic information. Okay, so now this next thing he does here, this summary table, I have not found any particular value to this, so I'm not going to go over this. Okay, I know I'm covering this kind of superficially, but it just doesn't seem to me to be worth the effort. It's just his way of kind of organizing things, and I don't see the value, to be honest with you. Okay, so here's the requirements, here's the assumptions, the populations that you take the samples from. The sedans, the small cars, the luxury cars, they have to be normal. They have to be normally distributed, okay, or at least approximately normal. The samples have to be independent. That's almost always true. The variances of the population must be equal. Okay, now keep in mind that's for this version of the test that we're doing. As far as I know, there would be a slightly different test if the population variances were not equal. But what this is saying is, hey, listen, the variances of the population, can't be significantly different. The variance of the sedans, and the luxury, they have to be about the same. And that kind of makes sense, doesn't it? I mean, do you think that the variance, even though the economy of the miles per gallon of the small cars is going to be a different number, the X bar is going to be different than the miles per gallon for the sedan, but the variance is probably going to be about the same. There's no reason to suppose it's going to be wildly different. Okay. All right. Okay, so here's the requirements. Remember what the simple random samples are concerned. The simple random samples, that's where you don't have more than one way of getting there. So like if you're rolling the dice, you get a 3. But if you say, well, I'm going to roll the dice, I want to get an odd number, that's not simple, right? Because there's more than one way of getting an odd roll of the dice. So it has to be something simple, which certainly the miles per gallon is a simple random variable. Okay. All right. So here it is. Here's the steps. Man, what a mess, huh? Okay. The calculations themselves are very difficult. I won't say difficult. They're very time consuming. Let's put it that way. I think that's a fair statement. Okay. And here's all of the various definitions. This is all in your book. Okay. As always, we state the hypothesis, find the critical values, we compute the test value, we make a decision, and summarize the results. So here's the miles per gallon, okay? So we've talked about this a moment ago, or correction, we talked about this a while ago in a previous recording. This is what we're trying to figure out here, the miles per gallon. Here's a group, here's a group, here's a group. Okay, we got the hypotheses, everything, it looks good. N is equal to 12, K is equal to 3. Is that true? K is equal to 3. There's 3 groups, 1, 2, 3. N is equal to 12 because there's 4 here, there's 5 here, there's 3 here. 4 plus 5 plus 3 is 12. So the total number of data points is 12. The degree of freedom of the numerator is K take away 1, which is 2. Degree of freedom of the denominator is this. So I urge you, I beg you, write this stuff down when you're doing problems, because if you don't, you're going to be all mixed up, okay? The critical value you get is going to be from table H, okay? Easy enough to find that. You go to the back of your book, you find table H. Remember on these On the F distribution, you have a different table for each alpha. Okay, each alpha gives you a different table. So once you have your alpha, then you find the appropriate table, and then you find the appropriate critical value based on the degrees of freedom. So in this particular case, this is the miles per gallon problem, example 12-1. We have an alpha of 0.05. So up here's the alpha, that's 0.005. So that's not the one we want. Here's 0.01, that's not the one we want. Keep on going. 0.025, 0.05. This is the one we want. So I can try to zoom in a little bit here, maybe. It's pretty hard. Just look in your book, folks. So it's 0.05. We have degree of freedom of the numerator. We have degree of freedom of the denominator. So let's find what we're looking for. Okay, the degree of freedom of the numerator, that's k take away 1, that's 2. Degree of freedom of the denominator is 9. Okay, so numerator is 2. That's the top guy is 2. There it is. That's the appropriate column. And then the appropriate row is 9. I claim is 4.26 is going to be the critical value. Okay, let's bounce back to the example here from the book. Here it is, 4.26. Okay, so we're good to go. So now we got to compute the test value. This is the hard part, obviously. Okay. I want to let you work your way through this and convince yourself if everything is correct. But if you bounce back and forth between here, this example, and the formulas, you see it's not as hard as it looks. I swear to you, it's not. It's just not as hard. It's not as hard as it looks. Okay? You take all of the data values, the summation of all the x's, divided by capital N. That gives you the grand mean of 33 point something or another. You find the between group variance. Here's the formula for it. Write that formula down. Calculate it out. The within group, again, it's just plugging things in. As long as you write down the formula, it's just plugging stuff in. You could literally be watching the Kardashians while you're doing this. It is not that hard. Then you find the F-test value. You come up with a number, 4.83. Well, the critical value is 4.26. Our test value is 4.83. Our test value is in this critical region here. It's in the reject the null hypothesis region. So there is enough evidence. So we reject the null hypothesis and we say there is enough evidence to conclude that at least one mean is different from the others. Okay. Now, I'm going to whip this out real quick. This is his little summary chart. I don't see any particular value to that, but you're welcome to look at it if you like. And then the p-values are pretty much found the same way as we've done before. I think I'm going to have a problem on Canvas. It illustrates how to use p-values. I'll let you look at this, but I think that's all I want to talk about for section 12-1. Now in 12-2, we're going to see that here in just a second. Oh, got a timeout here. Okay, but in 12-2, here's the bottom line here. In 12-2, we say to ourselves, okay, fine. We've rejected the null hypothesis. I'm convinced now that there is a statistically significant difference between these means. At least one of the means is significantly different from the other means. But what do I do next? How do I know which one it is? I don't know which one it is. If I need to know which one it is, then we do the technique that's in section 12-2. There's 2 different tests out of many. There's a whole bunch of them, but he's picking 2. We use one of those 2 tests to decide which of the X bars is significantly different. Okay, so we'll see that in the next section videos in section 12-2.